Hey there! In this video, I'm going to help you how to use the Fundamental Theorem of Calculus to solve definite integrals. But first, let's remember what does the theorem says.
The fundamental theorem of calculus. We're going to need a function f of x continuous on a closed interval a, b, and a capital letter f of x, an antiderivative of this function. And if that happens, then we have that the integral from a to b of f of x dx is going to be equal to the antiderivative evaluated on b minus it evaluated on a. That means the upper minus lower. Remember that, upper minus lower.
Let's begin with this example. Clearly, this is a definite integral. We have values here. But we're going to begin as we already know how to do with indefinite integrals. We have the integral of a sum. So we remember the integral of a sum is the sum of the integrals. So that means that I'm going to work with each term here, integrating, and then just adding them, okay? So for x squared, remember the exponent law, that is, as I'm going to add 1, okay? So this is going to be x elevated to 2 plus 1 over the same number plus 1, plus we have here as a sum, and we have the coefficient, which came right here. We know the properties of the integral, and continue with the exponent rule. So this is going to be, we understand here that this is going to be x to the power 1, so we add 1 to that, so it's going to be 1 plus 1 under the same number, plus, and we have a constant here. But we already know that the integral of a constant is the constant times x. So this is going to be 7x. Now we're not going to write a plus c here like we already used to when we have an indefinite integral. We're going to evaluate as the Fundamental Theorem of Calculus says. Okay, so we're going to notify. We're going to use the symbol of letting know that we're going to evaluate, which is a little bar here with the 1 and the 3, which are the numbers that are expressed here. Okay, so let's simplify a little bit. This is going to be x cubed over 3 plus 5x squared over 2 plus 7x, and now we can evaluate. So remember, the upper limit minus the lower limit, upper minus lower. Okay, so I'm going to evaluate here 3. That means that every time I see an x, I'm going to replace it by 3. So this is going to be 3 to the power 3 over 3 plus 5 times 3 squared over 2 plus 7 times 3, and then I'm going to subtract what the expression is going to give me 1, and I evaluate 1. Okay, I recommend that when I write a minus here, write a parenthesis, so it's kind of a reminder that I have to subtract everything that comes late. So this is going to be 1 to the power 3 over 3 plus 5, 1 squared over 2 plus 7 times 2, and then I'm just going to continue simplifying. Okay, so we have that this is 27 divided by 3, which is 9. This is 9 times 5, which is 45 half. 7 times 3, which is 21, and continue simplifying. So this is 1 over 3, but it's going to be subtracted. So this is minus 1/3. Here I have 5 half times the minus, which is going to be minus 5 half, and 7 times 2, I'm sorry, here this is a 1, and 7 times 1, which is 7, but it's going to be minus 7. And continue simplifying. Okay, I observe that I have the constants here, so this is going to be 7 times 21, which is 30, minus 7, which is 23, 45 half, and I have a minus 5 half here, same denominator, so I can subtract. This is 40 half, but 40 half is 20. So I have a 20 here, and the plus 1/3. Okay, so this is 43 plus 1/3. So finding the common denominator, which is 3, I'm going to have here that this is going to be 1, and this is a minus. Here, I forgot to write the minus. And this is going to be 129 third minus the 1/3. I forgot here, remember that this is going to be a 1 minus 1/3. And this is going to give me a 128 over 3. And this is going to be the answer for this integral. Let's continue with this example. We have the integral from 0 to 4 of the square root of x times 2x plus 5 dx. Okay? Now, to proceed, I recommend, we don't have a rule for the product directly, so my recommendation is that when we have a square root of x, to write it as an exponent expression. So square root of x is the same as saying x to the 1/2, okay? So if I write it there, you're gonna see that it's gonna be more comfortable to work with. So this is x to the power 1/2 times 2x plus 5, and then I just continue distributing and simplifying. Okay, so this is the integral from 0 to 4, and I multiply. So this is gonna be 2 x to the 1/2 times x. Remember that this is the same as saying x to the power 1. And when we multiply, we remember that we're going to add the exponents. Okay, so 1/2 plus 1 is the same as 1/2 plus 2/2, which is gonna be 3/2. So we have 2x to the power 3/2. Plus, and when we multiply here, we're gonna have 5x to the 1/2. So this is more comfortable to work with because we're going to use the exponent rule, okay? So we have 2 and x to the, and remember that we add 1. So this is gonna be 3/2 plus 1, the same number here. Plus, we have a plus here, 5x to the 1/2 plus 1 over the same number. And remember that we're not going to evaluate, we're not going to write plus c, we're going to evaluate. Okay, so we're going to evaluate from 0 to 4, therefore this notation. Okay, simplifying a little bit here. So this is gonna be 2x to the 3/2 plus 1, which is gonna be 3/2 plus 2/2, which is 5/2. Same number here. Continuing here, this is half. 5x to the 1/2 plus 1, which is 1/2 plus 2/2, which is 3/2, over the same number here, and then we're going to evaluate. Now, dividing by a number, by definition, is the same as multiplying by the reciprocal. Okay, so dividing by 5/2 is the same as multiplying times 2 over 5. So this is x 5/2, same process here. So this is 2/3, multiplying by 2/3, and simplifying, so it's gonna be more easier to evaluate. So this is 4 over 5. We continue right here. This is 10 over 3, 10/3. And now we evaluate, okay? Now for this number here, remember that is lower minus, upper minus lower. Okay, so when I substitute the 4 here, I have 4 to the 5/2. Okay, so my recommendation when we work here with this kind of exponent is to write it in radical, going back to the square root. So this is the same as saying the square root of 4 over 5. Remember that this number go here and this number go here. So since it's a square, there's no need to write it there. Okay, and we can solve it. I mean, you can find out how much is 4 to the power 5, or separate it in groups of 2. So this is the same as saying 4 squared times 4 squared times 4, 1. 2 plus 2 is 4 plus 1 is 5. Okay, so this is like they cancel. So this is going to be 4, the square root of 16. This is 4, and the square root of 4, which is 2. So we have that this is going to be 16 times 2, which is 32. And kind of the same thing is going to happen here with the 3 over 2. Okay, the only difference is that here we have a cube, and we're going to have that this is the square root of 64, and the square root of 64, which is going to be 8. Okay, so I'm going to write here 10/3 times 8. Okay, so this is going to be 10/3 times 8 minus. Now remember that is upper minus lower. So I'm going to evaluate here the 0, but the comfortable thing about 0 is that 0 elevated to any number different from 0 and non-negative is going to be 0. So 0 to the 5/2 is going to be 0. 0 to the 3/2 is going to be 0. So the whole expression is going to be 0. So I'm just subtracting 0 here. I don't even have to write it. And just continue simplifying here, okay? So we have 4 times 32 over 5. Okay, so I'm going to do the product here so you can know where I got it from. So this is going to be 128 over 5 plus 8 over 3. And I need a common denominator, which is gonna be 15. Okay, so I'm going to multiply here by 3. And then I'm going to multiply here by 5. Okay, so 128 times 3, which I have here 3 times 2, that is 6, times plus 2, which is 8, so this is 384. Times here, times 5 is going to be 400. And just finish the sum, which is going to be 784 over 50. And here we have the final value.